Okay. Something happened.
Only applesauce.
All right, let's go to part 1 then of the preparation assignment. Okay, question 1. When given a sample, what is the formula for the point estimate for a population proportion? Explain which each variable stands for in your formula.
X over N, where X is the number of successes and N is the number of trials, or like the sample population.
Yeah.
Yeah.
And then 2 is pretty similar. What is the formula for the one proportion confidence interval for one proportion? So what I got was the P little bar thing plus or minus the Z, which is the 95 or 99 or what is it, 90%, and then you times that by the pretty much the standard deviation equation. So
that sounds right.
K3, what is the condition required to build the one proportion confidence interval above? What'd you guys get?
Those same requirements for the right? Interesting they didn't word it that way, but just that n times p hat n, and then the other formula is the n times 1 minus 10. So they both have to be over 10.
Yep.
Yeah.
Yeah, I mean, these are just equations that we have to follow. 4, if no prior estimate for the population proportion, P is available. What is the sample size formula to get the needed sample based on desired margin of error? Explain what each variable stands for in your formula. So what do you guys get for 4?
The N equals Z over 2M with all that like square rooted.
Mm-hmm. So M being the margin of error, and then the Z is whatever confidence interval we want to find. What percentage confidence interval we want. So. Okay. 5. What is the test statistic for hypothesis test regarding the population proportion? And what I got was it's the bar P minus P, all that over the square root of P parentheses 1 minus P over N. So it's the standard deviation.
Right.
So
yeah.
And then for 6, what are the conditions that need to be satisfied so the sample size is large enough that the central limit theorem suggests the sample proportion P bar is approximately normal?
It's those two greater than or equal to 10 equations. If it passes those two, then it's good.
And then this one is different from the 3 because we're only using P. We're not using the bar P.
Oh, yeah, that's true. That's a big difference.
So, I mean, that really, I guess, makes a big difference. So, all right, well, let's go to part 2 then?
Sure.
Yep.
Anyone has any questions? I mean, pretty straightforward so far. So
Yeah.
I still get confused with p hat and p, but that's okay.
the way I think of them is P is like the sample size over the smaller number, whereas the P hat is the opposite. It's the X over N. Does that make sense? Probably not. That's the way I kind of remember.
Well, the only thing that makes sense for me is that the p hat was the point estimate. Full
Yeah.
proportion. That's the only point. And the other p is just population, I guess.
Yeah. Okay, so 7 in October 2008 poll, 684 of 1,006 randomly selected college students reported that they had been involved in an automobile accident within the last 5 years. So A, find the proportion of those surveyed who have been in an automobile accident in the last 5 years.
That's 684 over 1,006, which would be 0.67 or 0.68. I don't know how much. When it's 0.699, wouldn't we like on answer sheet round it up to like 0.68?
Yeah, I think so.
Okay.
Mm-hmm.
But then again, I mean, when we're doing the calculations, I think it might be better to include, 3 or 4 decimal digits, because I mean, that could influence the answer quite a bit. So, but
That's true.
Get to the end, yeah.
KB, check requirements in constructing a confidence interval for this data. So if you take 1,006 times the 0.68, whatever, you get 684, which is, of course, is greater than 10. And then you take 1,006 times 1 minus the 0.68, that's 322, which is also greater than 10. So the requirements are met. That's what I got. So.
Yeah. I think requirements are met.
Okay, C, determine the margin of error for a 95% confidence interval based on these data. So what do you guys put in for your calculation then?
Well, you'd start off with that 1.96 for the 95%.
Yeah, the answer I got was 0.0288.
Yep.
Yep.
And we just follow the formula from, I guess, question 2 from part 1, but we just take out the p hat. So, and we get, yeah. KD, construct and interpret the 95% confidence interval for the proportion of those who have been involved in an automobile accident in the last 5 years.
And this would be the low bound 0.6511 and the high bound 0.7087. Just because you take the margin of error and then you plus or minus it to the proportion, the p bar. I don't know the right name to that, but I think we all understand with the p bar thing.
I think Garth has it right with the p hat. Because
P hat.
Yeah.
That's what they call it, but I don't know.
P hat. Okay, cool.
Thought it was HUD first, but
Yeah. So, but yeah, that's what I got too. Because I mean, we just take the 0.68 and we add 0.028 and then minus 0.028, and we get the 0.65 and the 0.70. What you got? So.
Yeah.
mm-hmm.
KE, how many college students should you survey if you want a 95% confidence interval with a margin of error of no more than 0.015?
That's that solving for N again.
Yeah, that's the solve for n. So the number I got was 4,269.
Yeah,
And
just
that's
those.
whatever 1.96 over the 2 times 0.015 and all that squared.
Right.
So
Yeah, we always round up, so that's
it's confusing because there's another equation where you have to times it by p parentheses 1 minus p, and you don't times it by 2 or something like that too. All right, 8 hypothesis test. Now you are interested in testing a claim that over 60% of all students have been in a car accident within the last 5 years. Use the same information as above and use a level of significance of 0.05. So state the known alternative hypothesis. I got the null is 0.6 and the alternative is greater than 0.6. So what you guys got?
Yes.
Okay, and then compute the test statistic. I got 5.174.
Yeah. So did I.
And C, determine p-value based on test statistic. Sketch your p-value on the normal distribution curve with the test statistic labeled.
It's pretty much 0.
Yeah, 0.00. Yeah, it went forever, but yeah, 0. And then based on that, we're gonna, because it's not greater than the 0.05, we're gonna reject the null. What you guys got?
Yeah, reject it.
And then E, what were your guys' conclusions for it?
Then there is sufficient evidence to conclude that the true proportion of students that have been in a car accident within the last 5 years is greater than 0.6.
Yeah. Yeah, we just make sure it's sufficient evidence that there is. Yeah. Okay. Well, are there any other questions before we in the broadcast? Before we move to the quiz, or no?
Mm,
Or I mean, in the broadcast, is that okay?
Yeah, that's fine.